In this video, we'll talk about the polar form of a complex number. Now, this is very similar to the polar form of a vector, and it is a way to describe a complex number as a distance and an angle on an Argon diagram. So an Argon diagram, just a quick recap, is like a Cartesian plane, but the y-axis is in units of I, which is the imaginary number, and x-axis is as normal, goes from 1 to the positives and to the negatives. Okay. To start off, let's draw an Argon diagram. The y-axis, the x-axis label, that will be the imaginary, so I am z in this case. So the real z. Let's set a point. Let's say that's point A, connected from the origin. So put a perpendicular line. That would be the distance y. That would be x. That will be r. And that point A is x plus y I. And that's theta. And our imaginary number z is x plus y I. Okay. Now if we look at the diagram, that's a right angled triangle here. So that is a right angled triangle, which means that we can use Pythagoras Theorem and the trig identities such as sine, cosine, and tan. Okay, now looking at this triangle, we know that x is equal to r cos theta. This is because cos theta is x over r, and we just multiplied r on both sides to get x equals r cos theta. Now, what about sine theta? Sine theta is equal to y over r, which means that y is equal to r sine theta. Now we can substitute, well, we can replace x with r cos theta and y with r sine theta. Yeah. So the complex number z equals r cos theta plus r sine theta I. We can group that, and it becomes r cos theta plus sine theta I. And instead of having to write cos theta plus sine theta I every single time we solve a complex number equation, we simply denote this as cis theta. Okay, so cis theta is equal to cos theta plus sine theta I. Okay, sine theta I. And therefore, a polar form of a number, of a complex number, is r cis theta. Okay, now you should notice from vectors, but r is equal to the square root of x squared plus y squared. This is Pythagoras Theorem. So r squared equals x squared plus y squared. So r is equal to the square root of x squared plus y squared. Okay, so that is the magnitude, or it's called the modulus. Modulus of, in this case, it's z, because our complex number is z. So the modulus of z, and we write that as square line z and a line. Okay, kind of like the absolute value sign. And theta is the angle measured from the horizontal axis anti-clockwise. So we measure the angle this way, just like a unit circle. And how we measure the angle this way, it's exactly the same as that. And just one more thing, each complex number has more than one representation of its polar form. So what I mean is that we might have a complex number. It might be like 4 cis, let's say pi over 2. No, pi over 3. That could be a polar form of a complex number, but that's equal to 4 cis 7 pi on 3. Because what we just did was we added plus 2 pi, and we know that 2 pi is one full rotation of the unit circle. Now you should know that from your trig equations and functions and stuff that one full rotation of the unit circle will bring a point back to its original position, and it won't change the equation or the function. So what you can do is you can keep adding 2 pi and 2 pi for an infinite period of time, and basically the actual values of the equation is different, but the actual function of the equation is the same. So this number could be different, but the two equations would still be equal, or the two complex numbers. So sometimes we write the polar form of a complex number as r, not r equals, r cis theta, so that's our whatever the angle is, plus, now we can add 2 pi infinite number of times, right? So we put 2 n pi, and now n is just an integer. Okay, n can be both a negative and a positive, because it doesn't matter which way your point does a full rotation, because even if it goes to the negatives, it will still end up in the same position. So that's something to keep in mind. Might become important. Alright, now let's solve a few questions. Question 1. First, express 1 plus square root I as polar form. Well, in polar form. So, because you're just getting started, let's draw an Argon diagram, a very simple one. Goes 1 horizontal and square root of 3 I. So our point would be here, connected with the origin. You know that this is square root of 3, that's 1. It's out of scale, by the way. That's theta, it's r, that's all we need. So let's do this. Well, first we're going to find the r. R equals x squared plus y squared and the square root of that. In this case, 1 is x and the square root of 3 is y. To substitute, 1 squared plus square root of 3 squared equals 4, 2. Therefore, we know r equals 2. Now we need to find the value of theta. So we can do this in 3 ways. We can either use sine, cos, or tan. Usually I use tan because you'd be given the y and the x, and you can just use tan easily without having to calculate r in the first place. So let's use tan. Tan theta is equal to the square root of 3 over 1. That's equal to the square root of 3. Now you should know exact values by now, and tan theta equals pi over 3, square root of 3, and theta should equal pi on 3. Okay. If you need the exact value table, go sine, cos, tan, and you want to write 0, 1, 2, 3, 4 on sine, 4, 3, 2, 1, 0 on cos. We'll do sine and cos first. So divide all of them by 2 and put a square root sign on top. Just an easy way of memorizing it. Do the exact same thing for cos. That should be in the bottom. Oh no. 4, 3, 2, 1, 0, 2, 2, 2, 2, 2, square root, square root, square root, square root, square root. That simplifies to 1, that's 0, that's 0, that's 1, and that is half, and that is half. That's an easy way of memorizing the exact values. For tan, it just goes, so tan 45 degrees is 1, and then if you move to the right, you multiply square root of 3, move to the left, divide by square root of 3, write it as that, or rationalize it, so it becomes that, square root of 3 over 3. And go once more, that's 0, and go once, that's undefined. Okay, this is because a tan graph, it goes something like this, and it ends here. That just keeps repeating, and the gradient at this point is 0. That's why we get an undefined result. But that's for your trig functions thingy. We're looking at complex numbers. Now let's try another example. So we had question 2, maybe 3 plus, let's do minus, 3 minus 7i. Find the polar form of this complex number. That's x, that's y. So we'll do it without the diagram. R equals square root of x squared plus y squared. X is 3, so 3 squared plus negative 7 squared be 9 plus 49, 58. And can we simplify square root of 58 to 29? We cannot. So that is our R value. Oh, we didn't finish question 1. So let's write the polar form down. So it's 2 cis pi on 3. That's our polar form. Back to question 2. What are we up to? Oh, yeah, theta. So theta is equal, well, to the inverse tan of y on x. So it'll be negative 7 on 3. Now you want to put that in your calculators, and we get, and that's negative 1.17 radians. So our polar form is square root of 58 cis negative 1.17 radians. Now let's try 2 more examples. So, sorry. So question 2a. Convert square root of 2 cis pi on 3 to the form of x plus yi. So that's what we have to do. We need to convert that polar form into Cartesian form. Okay. So we know that's r, it's theta. And let's draw that quick diagram again. So that's point there. That's y, x, r, theta. So x equals r cos theta. Y equals r sine theta. So we're going to use this to find x and that to find y. We have r and theta, so that's substituted in. X equals square root of 2 cos pi on 3. Okay, exact value time. Cos pi on 3 is half, so x equals square root of 2 on 2. So that's equal to half. Now y. Y is equal to the square root of 2 sine pi on 3. Sine pi on 3 is square root of 3 on 2. So y is equal to root 6 on 2. And therefore, our Cartesian form is square root of 2 on 2 plus square root of 6 to I. Now we can, if you want to, you can factorize this into like square root of 2 on 2, 1 plus square root of 3i. Oh no, I goes inside the bracket, like that. Now let's try one more example and we'll leave it there for today. So part B. So we had 3 square root of 2 cis negative pi on 4. That's r. It's theta. Well, first we can calculate x. Oh no, let's calculate x and y. X equals r cos theta. In this case, r is square root of 3 square root of 2, sorry. And cos negative pi on 4. Now, if you're not familiar with negatives, you can always add 2 pi and make it into a positive, but we'll just go with a negative in this video. Let's draw a unit circle. I don't draw the circles. And so that's here, and that would be pi on 4 and negative. Okay, so this angle here is theta, and that would be equal to pi on 4. And since we're looking at cos, and cos is positive in both quadrant 4 and quadrant 1, we just need to do this: 3 square root of 2 cos pi on 4. Okay, because we express the angle here as 2 pi minus theta, and since we subtracted pi on 4, our theta is pi on 4. Now you should know this from your trig equations. Okay, so that's equal to 3 square root of 2 times square root of 2 over 2. That square root of 2 times square root of 2 is 2. 2 and 2 cancel out, so we're left with 3. Alright, now let's do y. Y equals r sine theta. R is 3 square root of 2 sine negative pi on 4. Going back to the exact same diagram, but we're looking at sine now, which is the y coordinate. So sine is positive in the first quadrant, but it is negative in the fourth quadrant. So what we need to do is we need to put a negative in front of the sine, and then use pi on 4. 3 square root of 2 times negative square root of 2 on 2. We do the exact same process. This times this is 2. That divided by 2 is 1, so these all cancel out. And there's a negative at the front. So our final answer for y is negative 3. Make that into Cartesian form, so it's 3 minus 3i, and group it by 3. So it becomes 3 bracket 1 minus I close bracket. And that is our Cartesian form for 3 square root of 2 cis negative pi on 4.